content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, we will analyze some of the most significant industry shifts in recent years, including the substantial updates to the 2026 National Electrical Code. The National Electrical Code is revised every 3 years, impacting the design, installation, inspection, and maintenance of electrical systems across the United States. This code cycle prepares the electrical industry for a future that is safer, more efficient, and better organized. In this episode, we will explore the biggest changes, what they mean in the electrical industry, and how we as the electrical industry can prepare. The 2026 National Electrical Code is more than a mere update. It acts as a roadmap for the upcoming decades of electrical design and safety. The 2026 National Electrical Code introduced substantial changes that reflect the rapid evolution of the electrical industry. With nearly 4,000 public inputs and hundreds of revisions, these updates represent a significant shift in the approach to the electrical safety and technological advancements. The primary themes of the 2026 National Electrical Code revisions includes expanded safety protocols, addressing new technologies and configurations, a reorganized code structure aimed at enhancing clarity and usability, a focus on emerging technologies such as electric vehicles, infrastructures, and energy management systems, alignment with future developments, providing a foundation for the National Electrical Code 2029 cycle. These modifications are not merely incremental adjustments. They constitute a fundamental restructuring of the National Electrical Code framework and objectives, preparing the industry for future challenges in electrical safety and innovations. The following are some key articles that have been reorganized in the 2026 National Electrical Code cycle. Article 110.3b, Manufacturer's Instructions. Article 110.16, Arc Flash Hazard Management. Article 120.7 B and C, Power Control Systems. New Article 120.82 B, General Lighting Demands. New Article 120.82 B, General Lighting Load. New Article 120.82 D, Electric Vehicles Supplying Equipment Load at 100%. New Article 120.82 B, General Lighting Demands. New Article 130.50, General. Expanded Article 210.8, GFCI Protection. New Article 210.52, A5, Wall Receptacle Outlets Below Countertop. New Article 210.52, CA, Receptacle Outlets Below Countertops. Relocated Article 230.70A, Service Disconnect Locations. Expanded Article 230.70B, Service disconnect markings. Clarified Article 230.70F. Remote control. New Article 300.4. Limitation. New Article 300.13. Securing. New Article 408.6. Short circuit current rating and supporting. New Article 555.9. Engineered design. Clarified Article 55.13. Non-current carrying metal part bonding. Expanded Article 55.35. GFPE and GFCI protection. New Article 555.35. GFPE performance testing. New Article 625.5. Qualified persons. New Article 625.5. Field markings on EVSE. Enclosures. New Article 625.43. Disconnecting means. New Article 625.5. Field markings on EVSE. Enclosures. New Article 625.43. Disconnecting means. New Article 625.44. Equipment connections. The latest updates to the National Electrical Code, issued in 2026, introduce significant structural changes designed to improve navigation and usability for electricians, inspectors, and designers. These key updates include a reorganization of key articles, revised technical requirements, and expanded safety protocols. Reorganizations of key articles. Load calculations moved from Article 220 to Article 120. A major change involves transferring the requirements of branch circuits, feeders, and service load calculations from Article 220 to the newly expanded Article 120. This centralization streamlines code navigation, making it more intuitive and logically constructed. As a result, electricians, engineers, and designers working with crucial loads will need to familiarize themselves with the new location and structure of these requirements. Article 750, Energy Management Systems, relocated and renamed to Article 130. This renaming comes with the addition of detailed definitions for power control systems, emphasizing their roles in regulating energy flow, preventing overloads, and supporting intragation with renewable energy sources. The updated article incorporates smarter load management techniques, advanced monitoring capabilities, and enhanced safety features to ensure reliable operation of energy management systems. Chapter 8, Communication Systems, merged into Chapter 7. The reorganization combines the regulation for low voltage data communication cables with those for limited energy systems in Chapter 7. This consolidation Rules for low voltage wiring reduces redundancy and clarifies distinctions between traditional low voltage communication systems and modern integrated data systems. The unified chapter aims to improve clarity for installers, inspectors, and designers, facilitating compliance and safety. These structural changes aim to significantly improve the efficiencies with electricians, inspectors, and design professionals. All can locate relevant rules during constructions, inspections, and examination processes. Safety enhancements you should know. The National Electrical Code continues to prioritize safety, with notable updates in the upcoming 2026 revisions that address installation practices, fire prevention, and system robustness, thereby increasing safety for electricians, building occupants, and emergency responders. Article 110.3b, Manufacturer's Instructions. Manufacturer's instructions, installation instructions are now explicitly required to align with the National Electrical Code standards. While these instructions can exceed the maximum standards set by the National Electrical Code for enhanced safety or performance, they cannot be reduced. The mandatory code requirements. Acceptable formats for these instructions include printed manuals, digital QR codes, or web-based links, enabling easy access for installation and inspection purposes. Article 110.16, Arc Flash Hazard Management. The requirements for arc flash warning labels on non-dwelling unit services and feeder equipment have been significantly expanded through the removal of several words. Previously, the code mandated warning labels only on service and feeder equipment rated at 1,000 amps or higher. The updated regulation now requires labels for non-dwelling distribution equipment, with the labels including specific information such as the date of the arc flash assessment. Revised or new code language specifies that in non-dwelling units, a permanent arc flash warning must be affixed to service and feeder equipment rated at 1,000 amp or more, including switchboards, enclosed panel boards, and meter socket enclosures. An arc flash event can reach temperatures of up to 35,000 Fahrenheit, transforming metals from a solid into a vapor and releasing molten shrapnel that can cause severe burns or fatalities. The absence of requirements for such labels in dwelling units is due to the typical single-phase 120 volt to ground or 240 volt line-to-line voltage. In this context, arc faults tend to self-extinguish at each zero crossing of the waveform. Conversely, three-phase arc faults can be sustained in accordance with IEEE 1584 standards. The hazard warning labels must be permanently affixed to the equipment and cannot be handwritten, as stipulated in Article 110.21b. It must be clearly visible to qualified personnel and installed accordingly to industry practices. The label must contain the following information. The label must contain the following information. The labels must include the nominal voltage, arc flash boundaries, incident energy or required PPE level, date of assessment. Article 120.7 B and C of Power Control Systems provisions offer guidelines for load calculations utilizing a listed PCS with a control setting not exceeding 80% of the overcurrent protective device. This approach aims to prevent overload conditions in branch circuits, feeders, or service conductors. Employing a PCS for load management can also circumvent costly upgrades when panels or services are operating near capacity. The updated or revised code includes PCS control settings, which stipulates that when used in load calculations, the control setting must not surpass 80% of the overcurrent protective device rating for the monitored circuit. Furthermore, Article 120.82b introduced a new regulation clarifying the methodology for calculating load managed by a PCS by distinguishing between control and non-control loads. This difference provides clear guidance for accurately sizing loads with PCS technology. An informational note has been added to exemplify load calculation procedures when a PCS is employed. The new or revised language concerning Article 120.82c specifies that the load on the branch circuit, feeder, or service must equal the sum of the controlled loads as defined in Article 120.7c1 and the non-controlled loads as defined in Article 120.7c2. Another update modifies the demand load for optional dwelling unit load calculations from the initial 10 kVA at 100% to 8 kVA at 100%. This change results in a reduced demand load, as the previous treatment of the first 10,000 kW of load at 100% has been decreased. The revised or new code language states general loads, indicating that the demand load must not be less than 100% of the first 8 kVA plus 40% of the remaining kVA for substantial loads. Finally, based on studies conducted by the Department of Energy, the general lighting and receptacle load in a dwelling unit has been reduced from 3 VA to an evidence-based value of 2 VA. The recent revisions to the electrical code introduced substantial changes that influence electrical vehicles, supply, equipment, and safety protocols for outdoor outlets. New Article 120.82d, electric vehicle supply equipment load at 100%. For the dwelling unit optional method, the load associated with electric vehicle supplying equipment, EVSE, must be calculated at 100% without applying a demand factor, acknowledging it as a significant load. The new code specifies that the use of 100% of the EVSE nameplate rating in accordance with Article 120.57. New Article 130.50. General. The addition of power control systems, PCS, requirements for Part 2 of Article 130 enhances energy management systems, EMS. While traditional EMS monitors energy consumptions to reduce costs, PCS introduces capabilities to monitor and regulate loads, thereby preventing conductors or equipment overloads and improving overall system performance. The code now states that a PCS may manage generations, energy storage, load, circuit controllers, or other equipment, and may include protective functions related to EMS or grid interconnections. Expanded Article 210.8, GFCI protection. The requirements for GFCI protection of outdoor outlets in residential settings have been increased from 50 amps to 60 amps. This adjustment accounts for the availability of GFCI solutions and affirms that the hazards remain consistent. The revised code mandates GFCI protection for all outdoor outlets rated at 60 amps or less, located outside a dwelling unit, including those within garages, accessory buildings, and boathouses. These updates aim to improve safety and performance in residential electrical systems. GFCI and new SP GFCI requirements, expanded GFCI locations, and updated voltage thresholds, including special purpose GFCIs, SP GFCIs for higher voltages, circuit enhanced shock protection across more installations. SP GFCI, special purpose ground fault circuit interrupter. Requirements mandate 20 MA ground fault protection for equipment and personal. A ground fault protection for equipment and personnel on SP GFCI, special purpose ground fault circuit interrupter, requires SP GFCI, special purpose ground fault circuit interrupters. Requirements mandate 20 milliamp ground fault protection for equipment and personal circuits exceeding 150 volts to ground up to 600 volts, such as 277 volts or 480 systems, commonly used in commercial swimming pools, marinas, and industrial or heavy-duty outdoor equipment. Unlike 4 to 6 milliamp Class A GFCIs, the SP GFCIs, Class C, D, or E, are designed for higher voltage, allowing higher leakage current while preventing fibrillation. Key details regarding SPC T details regarding SPGFCI requirements include applications for the National Electrical Code 680.5 swimming pools, mandatory for specific high voltage, high amperage up to 100 amps circuits in commercial, industrial, or pool marina environments. The technical specifications must not exceed a 20 milliamp ground fault trip. Current focusing on reducing the risk of ventricular
Fibrillation.
voltage range used on circuits where voltage to ground is 150 volts but not exceeding 480 volts phase to phase. Identification often utilized in Class C 15 amp 15 to 20 amp milliamps. Identification often utilized in Class C 15 to 20 amps milliamps. Class D or Class E configurations. Safety standards comply with UL 943C for specialized industrial commercial safety devices. These requirements ensure that equipment with higher operating voltages, which may have normal or non-hazardous leakage, does not cause nuisance tripping while still protecting the users. HVAC units and outdoor equipment now fall under more rigorous GFCI protection requirements, meaning new breakers or devices on jobs you might not have expected before. The 2026 code introduced significant modifications concerning the placement of receptacle outlets in the kitchen area, with an emphasis on safety considerations related to hanging cords. Notable updates include the prohibition of receptacles outlets below countertops. Receptacle outlets are now prohibited within 24 inches beneath the countertop surface. This regulation was influenced by reports from the Consumer Product Safety Commission, which documented incidents where children sustained burn injuries from appliance cords dangling from kitchen islands and peninsula countertops. Revised code language. New Article 210.52A5 stipulates that receptacle outlets required by Article 210.52A2 and A3 when installed below countertops are not permitted within 24 inches of the countertop surface. New Article 210.52C4 further reinforced this requirement by prohibiting all receptacle outlets from being located within 24 inches of the kitchen countertop surface. These amendments are intended to improve safety within kitchen environments by minimizing hazards associated with appliance cords. Recent amendments to Article 230.70 covering service disconnect locations and markings introduce significant modifications that affect 1 and 2 family residents. Relocated Article 230.70A service disconnect locations. The service disconnect for 1 and 2 family dwellings are now required to be situated outdoors. The emergency disconnects provisions outlined in Article 230.85 have been eliminated. The revised requirement specifies that service disconnects must be located on the dwelling or within a visible range and not exceeding 50 feet from the dwelling unit, in accordance with Article 110.29. Expanded Article 230.70b, Service Disconnect Markings. The markings requirements for service disconnect have been clarified for better understanding. Notable points include for service disconnect other than those for 1 and 2 family dwellings, markings readings service disconnects must be applied on or adjacent to the disconnect. The markings should be durable, permanently affixed, and not handwritten, in accordance with Article 110.21b. For 1 and 2 family dwellings, disconnect enclosures are required to be marked emergency disconnect with specific criteria. Markings must be placed on the front exterior of the disconnect enclosure with a red background and white lettering. Letter heights must be at least half an inch. If the energy source disconnecting means is not adjacent to the service disconnect, a placard or directory indicating the location of all the energy source disconnecting means must be installed nearby. A clarified Article 230.70f, Remote Control. The requirements regarding remote disconnect controls have been clarified to emphasize that a device, such as a push button for a shunt trip breaker, is not considered a service disconnecting means. These modifications are intended to improve safety and accessibility in residential electrical systems. The National Electrical Code has introduced important updates related to damaged wiring and securing methods in Article 300. Key changes include damaged conductors and wiring methods. The NEC now requires that overheated, fire-damaged, or water-damaged conductors, wiring methods, and equipment must be replaced. This update clarifies that any damaged wiring and equipment are no longer considered safe for use and must be removed. Informational note references NEMA documents for evaluating fire and water damaged electrical equipment. New code language. Damaged conductors and wiring methods. Damaged conductors and wiring methods unsafe due to overheating, fire damage, corrosive influences, or water must be replaced. For guidance on electrical equipment and wiring methods impacted by water, see NEMA GD 1-2019. Evaluating water damaged electrical equipment. Now, securing methods. A new rule states that cable ties, supporting or securing cables or flexible raceways must be listed and labeled for that purpose. Revised code language. Cable ties used as means of securement and support. Cable ties must be listed and labeled for securing and supporting cables, flexible conduit, and flexible tubing. Cable ties fixing devices. If installed, these devices must also be listed and labeled for securement and support. Note that type 2S and 21S cable ties are evaluated for this purpose. These updates aim to improve safety and dependability in electrical installations. The recent update to Article 408.6 introduced significant changes concerning short circuit current rating and required supporting analysts for switchboards, panel boards, specifically for installations beyond single and two-family dwellings. The key points include switchboard and panel boards now must have a short circuit rating that is not lower than the available fault current on the line side of the equipment. The following requirements must be followed. The available fault current and calculation dates must be clearly marked in an easy, accessible spot on the enclosure at the supply point. The short circuit current rating of the equipment, based on the nominal circuit voltage and the overcurrent protective device, must also be marked in an accessible spot. All markings must conform to Article 110.21b. Documentation of the available fault current calculations must be kept and available to authorized personnel for inspection, installation, or maintenance. If modification impact the available fault current at the line terminals, then the available fault current must be recalculated to verify compliance with equipment rating. Field markings must be updated to reflect the new available fault current and the interrupting rating of any replaced or added overcurrent protected devices must meet or surpass the marked available fault current. For series combination systems, see Article 110.22 for additional guidance. These updates are vital for safety and compliance in electrical setups. New regulations have been introduced to enhance safety in electrical systems for marinas and docks, especially through clarification of Article 555.9, 555.13, and 555.35 in the National Electrical Code. Article 555.9, engineered design clarified. A new rule allows the authority having jurisdiction to require an engineered electrical design for peer distribution system in certain situations involving one and two family dwellings. For larger systems or multi-slip marinas, be prepared to submit engineered plans. This change aims to improve safety on commercial docks by ensuring proper design and installation. The new code states that documentation of engineering electrical designs must be provided upon request by the authority having jurisdiction. However, an engineered design is not required for one and two family dwelling units if the system voltage is 240, single phase, or less. Article 555.13, bonding of non-current carrying metal parts. Revision clarifies that only metal parts likely to become energized must be connected to the circuit equipment grounding conductor with a bonding conductor no larger than 8-odd copper. The updated code specifies that all non-current carrying metal parts that may become energized must be connected to the branch circuit or feeder equipment grounding conductor by a bonding conductor not required to be larger than a number 8. Article 555.35, GFPE and GFCI protection expanded. The 2026 National Electrical Code now mandates ground fault protection of equipment, GFPE, rated at 100 milliamps or less for both branch circuit and feeders supplying docking facility and piers. This requirement ensures that all circuits supplying structure over water or GFPE protected significantly reduces the risk of electrical shock hazards in marinas environments. A new Article 555.35 GFPE performance testing. A new requirement mandates that GFPE protection systems must be coordinated and performance tested by a qualified person. New Article 555.35 GFPE performance testing. A new requirement mandates that the GFPE protection systems must be coordinated and performance tested by a qualified person. Proper coordination of the GFPE devices is essential to protect. A recent amendment to the Electrical Code introduced several significant articles pertaining to electrical vehicle supplying equipment, with the intent of improving safety and installation standards. Article 625.4, qualified persons, stipulates that permanently installed electrical vehicle power transfer equipment such as level 2 chargers or higher must be installed by a qualified individual defined in Article 110. This requirement ensures that the installation adheres to the established safety and performance criteria. For additional guidance, refer to National For additional guidance, reference NECA 413 Standards for Installing and Maintaining Electrical Supply Equipment. Article 625.5 Field markings on electrical vehicle supply equipment enclosures mandate that enclosures bear permanent and visible markings on their exterior. These markings must display essential information, including such markings enable rapid verification of proper circuit sizing and short circuit ratings prior to energizing the equipment, particularly since EVSE installations may feature field adjustment current settings. For further details on the short circuit current rating, refer to UL 2594, Standard for Electric Vehicle Supply Equipment. Article 625.43, disconnecting means. Introduce an electrical. Article 625.43, disconnecting means. Introduces an emergency shutoff requirement for permanently connected EVSE. This enhancement aims to improve safety for emergency responders. For installations beyond single and multi-family dwellings, these electrical vehicle charging stations. For installations beyond single and multi-family dwellings, these EVSE units must be equipped with an emergency shutoff device located within site at a distance of between 20 and 100 feet from the equipment. This regulation facilitates swift disconnection of power during emergencies such as an electrical vehicle fire by first responders. The device must be clearly marked to indicate that the vehicle will remain energized even after the EVSE is de-energized. A new regulation has been enacted concerning receptacles for electric vehicle supply equipment, pursuant to Article 625.44. This regulation mandates that all 30 amp, 50 amp, 60 amp receptacles utilized for electric vehicle charging must be specifically listed for EVSE use. The primary motivation for this change is the increasing occurrence with receptacle failures, which frequently happens at connection points due to the elevated temperature under continuous load conditions, particularly with cord and play connections. Receptacles that are listed for EVSE are specifically designed and tested to withhold continuous loading, thereby ensuring safe and reliable charging over extended duration. The revised code language under Article 625.44b states that equipment which is handwritten must connect to the premise wiring using one of the following methods. The revised code language under Article 625.44b states that equipment which is hand fastened must connect to the premise wiring system using one of the following methods: non-locking 2-pole 3-wire grounding type receptacle outlets rated at 125 volts or 250 volts, single phase, in accordance with 15 amp or 20 amp, 30 amp or 50 amp, listed for EVSE and WPTE. Non-locking 3-pole 4-wire grounding type receptacle outlets rated at 250 volts 3-phase, in accordance with 15A or 20 amp, 30 amp, 50 amp, or 60 amp, listed for EVSE and WPTE use. Non-locking 3-pole 4-wire grounding type receptacle outlets rated at 125 volts to 250 volts, single phase, in accordance with 15 amps, 20 amps, 30 amps, 50 amps, or 60 amps, listed for the EVSE and the WPTE use. This modification represents a significant advancement in the enhancement of safety and reliability within the EV charging infrastructure. These regulatory updates demonstrate an ongoing commitment to safety and efficiency as the deployment of charging stations continues to expand. The recent updates to the National Electrical Code reflects a significant trend, adopting to modern electrical systems where traditional categories like low voltage are becoming obsolete. The recent modifications to the 2026 National Electrical Code have significant ramifications for the electrical industry, impacting various stockholders. For electrical contractors, anticipate an increase in devices such as GFCIs, labels, and emergency disconnects, just to name a few. Revise templates, drawings, and bid documents to conform with new location and requirements. For the inspectors, familiarize oneself with new placements of the articles. Recognize updated markings and labeling standards. Assess power control systems and emergency management systems. EMS installations in accordance with revised performance and listing criteria. For apprentices, study the reorganization of the code. Understanding the locations of The regulations is nearly as critical as knowing the regulations themselves. The implementation of these changes are profound for the electrical industry, whether engaged in design, installation, inspection, or project management. The updates in the 2026 National Electrical Code will influence how electrical systems are planned, installed, and maintained. Key insights to take away from this episode includes a proactive and comprehensive approach to safety from labeling to damage replacement, a code structure that reflects modern power systems, including EMS and electrical vehicle charging, efficiency and demand calculations aligned with current usage trends, the need for professionals to update their reference practices and training materials. The 2026 National Electrical Code is not merely a new addition. It signifies a fundamental shift in our approach to electrical systems in an increasingly electrified, smart power, and safety-oriented world. Join me on Wednesday, February the 11th, for another informative episode where we will review the necessary safety procedures outlined in the National Electrical Code. We will discuss common pitfalls to avoid and provide practical tips on how to prevent errors during inspections, ensuring safe, compliant, and reliable temporary electrical setups. If you're looking to expand your knowledge of the electrical standards, code compliance, and best practices, consider checking out the list of 60 best electrical podcasts available at podcast.feedspot.com. This resource is valuable for anyone aiming to stay informed, improve their skills, and deepen their understanding of electrical work and safety. Feel free to reach out through social media with any questions, comments, or topic ideas. You can find me on social media, Facebook, Instagram, YouTube, under the name Ask the Lady Electrical Inspector. Also, you can email me at asktheladyelectricalinspector@gmail.com for more in-depth discussion, feedback, or to share your specific electrical concerns. Together, we can keep our electrical systems safe, reliable, and up to code. Your involvement and dedication are vital to making our community safer for everyone. Thank you for tuning in. Until next time, stay compliant, stay safe, and keep the power flowing. Good night.